Okay, so now that we got the introduction out of the way, the first thing we're going to focus on here is a shift in the power, or at least the power supply, of how emerging manufacturing plants would operate. Now, in the sort of the beginning phases of this, particularly in the textile industry itself, there's a reason why these textile mills were built where they were. There's a reason why they thrived in Lowell, Massachusetts, or Lynn, Massachusetts, or places in northern England and in Manchester, and then eventually, of course, places like Liverpool, and even on the outskirts of London. And the key to that was water power. A lot of the looms that powered these, the power that powered these textile looms that allowed for an increased pace of production were really powered by rivers and water. So you can kind of look at examples here. This is an example of a water-powered mill. I'm not sure exactly where this is. My guess would be this is actually in Massachusetts. And if we look at the way things worked, it was often like, if you think of the way like a riverboat works, right? There's sort of a riverboat, the old kind of riverboats that you'd see in the Mississippi. You see them in old westerns and that kind of thing. You'd have this kind of massive wheel that would turn along the side. It wasn't propeller driven, and that would turn and move the riverboat through the water. Well, in the case of textile looms, it was the exact opposite. You had a kind of massive kind of wheel that was placed in the river, sometimes at waterfalls for obvious reasons. The power was much greater, but often on a kind of fast flowing river. And what that would do is the river would turn one of these massive wheels, which would then turn various other forms of mechanical crankshafts that would turn the looms to make the the massive kind of increase in production of textiles possible. You can see kind of examples of that here as well, right? These are the way these old looms worked, that they would turn this, you can see up here, this kind of shaft here, which would turn these belts, which would turn the looms to make various textiles and equipment. So what we're going to focus on is the shift from water power to steam power. And steam power not only makes this process far more productive, but liberates these mills from operating near water or rivers. And again, if you don't have the map here, but if you look at a map of Massachusetts and where a lot of these mill towns were, they were very close to water, or at least right beside a river. So it limited where you could actually build these things, right? You were limited to water supply at this point. But when there's a shift to steam, not only does it become more productive, it changes where these plants can actually operate. So if we look at the next example, or the next slide here, steam power is powered by the burning of coal, right? When we think of steam power, probably most of us think of early trains, right? Early trains use steam engines, and steam engines on trains effectively operated until probably the 1930s and the 1940s. I mean, we had trains that operated under gasoline prior to that, but the last kind of steam trains were still running in the 1930s and the 1940s. And the steam engine itself was developed by a man named James Watt in the late 18th century, an Englishman, or actually I think he was Scottish, named James Watt. And initially, of course, this technology doesn't catch on quite as quickly. For those of you that look at how technology gets developed, particularly in industry, it takes time. If we think of the automobile, the internal combustion engine is actually developed in the 1880s by Carl Benz, I believe, who becomes the guy behind Mercedes-Benz, Daimler-Benz. But in terms of mass use of the internal combustion engine in automobiles, you're not really talking till the 1920s, where most people are actually buying cars. So it's invented 25 years prior to that. And the steam engine is no exception. It's developed in the late 18th century, but you don't really get its massive application until at least the 1820s and the 1830s, with things like locomotives for the emergence of rail and train traveling, but it's also applied to any kind of industrial operation that was using water power as well. So if you look at these textile mills, they shift to steam power because it's far more powerful, it's more reliable, and it turns much faster and can increase the rate of production. But it didn't, as I said, it didn't use water, but it did rely on coal. Now, again, this is a big deal because now these mills are liberated from not necessarily being tied to water. But since coal was the principal fuel for the shift to steam, it means proximity to coal was now key. So if we look at examples specifically in England, if you look at the Lancashire textile mills, and Lancashire is in northern kind of what they call the Midlands in England, up around Manchester, Liverpool area and south of that. And that was close to these massive coal deposits. And it's part of the reason why the Industrial Revolution takes off so much in England as well, because England actually has a lot of coal. Still to this day, has a lot of coal. It's just not used because obviously coal as a source of power is on the way out because, as most of you probably know, it is a fairly dirty fuel, right? It creates a lot of pollution, which is why places like London, places like the Midwestern United States, New York in the 19th century were extremely polluted. In fact, you can look at pictures of London from the 1930s and the 1940s, and it looks very different than the London of today. For those of you that have been to London today, which is a post-industrial city, it's, pinks and whites and pastel colors, very light colors on the buildings. But in the 1940s, you could still look at all the soot from the factories in London that had existed from the 19th century onward. And it was a very kind of dark looking city because of all the pollution had basically colored all the buildings a dark color. And this is the beginning of the Industrial Revolution's dependent on fossil fuels, right? This is really when that emergence of carbon dioxide, things being put in the atmosphere starts. It's that shift from water power to coal. And as I said, coal deposits are key to this. In the United States as well. I mean, if we look at where a lot of the early steam-powered plants were, Pennsylvania has tons of coal fields, as does West Virginia. That whole part of the United States fueled the Industrial Revolution in the Northeast and what's referred to as the Midwestern United States, which is like Ohio, Michigan, Illinois, these places in the United States. And a lot of what it does is it also allows, as I said earlier, the pace of work is now more determined by management. Under the first kind of revolution in commercial capitalism where machines weren't actually used, management took control of how work was determined, but now with the emergence of technology, they have even more control over it. And it allows for these heavy machineries, and as I said earlier, a further de-skilling of labor. And this is why in the early Industrial Revolution, as technology being applied to the manufacturing of goods and products, we see a kind of large employment of both women and children. And I mentioned this a few lectures ago, right? For those of you that have ever read Charles Dickens, right? This is the phase of Industrial Revolution that he's describing in the 1860s and the 1870s in England, where children as young as 9, 10, 11, 12 would sometimes work in blast furnaces to make steel, or they'd work in the mining industry. Women especially were employed in mass numbers in the early industrial sector in the United States, especially in Lowell and Lynn, Massachusetts. And with the introduction of technology and the further de-skilling of the trade, they relied more and more on women and children, particularly unmarried women at this point. So women who would probably turn 16 or 17, many of them lived in the country, would come and look for work in these in these mills and the textile industry, and would eventually, usually once they get married, would probably leave the working world. And that was the key, right? When you rely on workers who see themselves as working just temporary, you can usually pay them less, largely because it's not going to be their entire life. And of course, children, it's fairly obvious, right? You can pay children very little to do these jobs. And of course, children are very unskilled. But if we look at the development here, when we start looking at steam and the steam power, you can just see the technology shifting. It's more sophisticated. You've got boilers. You've got, if you look at the wheel that's turned, you're getting a lot more power. And here's another example as well, if we look at the role of steam in the emergence of a much greater technological application to the manufacturing process. And there's another example here. This is probably, I'm not exactly sure, this is probably in Lancashire in England. All right. So what we're starting to see is a reliance on coal, the beginning of the dependency of the industrial sector on fossil fuels. We're seeing the pace of work is now much more determined by management. It allows for the heavy kind of application of machinery and the further de-skilling of work in this particular phase of capitalism. And what this will eventually lead to is this idea of the assembly line. All of that kind of application of technology and organization will culminate in the late 19th and early 20th century in the emergence of the assembly line and mass production. And this is where the pace of labor is controlled even more. And we'll also see a further detailed division of labor where workers become essentially interchangeable. At this point. This increase in machine use meant, as I said, a further de-skilling of industry, and also meant that management exercised far more control. It also meant it was more difficult to get into these businesses, because if you had to buy and invest in large machines, steam-powered turbines and these kinds of things, you needed a lot of capital to get going. So the actual entry point of these industries was becoming more difficult as these kind of industrial colossus emerged in the United States, specifically in England as well. And again, it meant the further division of labor. Workers became interchangeable. And if we look at, one of the readings that you guys had to examine this week in Frederick Winslow Taylor's on the principles of scientific management, a lot of it emerges from here. And here's kind of a specific example where he says the emphasis should be on training men rather than finding the right man. Prior to the beginning of technology being applied to mass production, right? We saw how merchants, yes, didn't necessarily need skilled master craftsmen, but it still wasn't as easy as labor would become under the industrial process. If we look at prior to the application of technology, yes, it was a de-skilling of, say, the master craftsman trade where he made the whole shoe, but you still needed the dexterity of workers' hands in shaping the leather, in sewing laces, in binding the leather, and dyeing the leather, all these kinds of things. It was way more de-skilled than the master craftsman, but a little bit more skilled than when we get to this phase of the Industrial Revolution with the application of technology. And what this meant was workers were virtually interchangeable. It didn't really matter who it was. You didn't necessarily need to find the best worker. As Taylor himself said, you needed to focus on training the men rather than finding the right man. Well, what does this mean? As I said, prior to this, labor was de-skilled, but it was often about finding good workers. Now it was about training workers properly. In this sense, it was actually better to have workers who had no skills at all, because it meant that management could shape them and mold them into the kind of worker that they wanted and train them specifically for what they wanted them working on in a particular stage of production. It also led to what we refer to as the continuous production process. That is, production was continuous. When we see the application of assembly lines, first in something like the meatpacking industry, which we'll look at in a minute, it was continuous. It wasn't like in those early shops where you had, yes, a division of labor, but it wasn't this continuous assembly line of production. And this is what we get as an innovation in the late 19th century. So we get the application of machines, but this continuous movement of production. And it's a problem. It meant that the industrialists had to become very aggressive in seeking out new markets, else you would have all this product and nobody to sell to. And in the readings, you saw how this created what was modern advertising. And we'll look at that more in detail when we look at vertical integration. But specifically, this idea of manufacturing the demand, right? Once you've created all this product, you need a market, you need consumption. So they invested in divisions within the company that would create and manufacture that demand, which is the beginning of advertising. But let's look just quickly at the beginning of the assembly line, or what is often referred to as the disassembly line in the case of the meatpacking industry. So the two biggest examples of the emerging assembly line is the meatpacking industry, and probably one that you're more familiar with, which is Henry Ford's assembly line, when the assembly line is applied to the making of automobiles. But in the case of meatpacking, what you had was a very hyper-rationalized system of the disassembly line, obviously because they're literally disassembling animals. Now here's an example at the Swift & Company meatpacking plant, most of whom were located in Chicago. In fact, Chicago was known in the late 19th and early 20th century as kind of butcher to the world, because most of the meat in America was packed in the Chicago slaughterhouses. Became these massive corporations in Chicago and exercised a tremendous amount of power in the Chicago and surrounding Chicago economy. So when we look at meat packing, as you can see here, it's this continuous flow of production. So what you have is you have all these men standing here, many of whom may have been butchers, but probably not. They don't necessarily need to be that skilled. And what you have, in this case, it's hogs moving on this, this right here moves at a continuous pace. And as it moves by, each one of them is involved in a different process of the slaughter, right? For those of you that are vegetarians, apologies, because this is pretty disgusting for you, but this is a sense of how it worked. So it's interesting that the kind of first instance of the assembly line emerges in something that is very basic in foodstuffs. Just like when we see the emergence of capitalists' mode of production emerges not in the manufacture of goods, but in the agricultural sector in England, right? This idea of the emergence of commercial agriculture makes possible of everything. And we see this at the beginning of the assembly line when we look at something that is basic, right? Everybody needs to eat, and it's applied to the meatpacking industry. And these meatpacking companies become absolutely huge. Now, of course, one person who was really interested in the techniques that were being pioneered in the meatpacking industry was a man named Henry Ford, who would go on to found the Ford Motor Company. Now, Ford was inspired by the continuous flow of production in the meatpacking industry, and he started to apply this to the making of automobiles, and this particular idea of a continuous assembly plant. And we see the assembly line in Ford when it was introduced in 1913. This is an example of a Ford plant, probably the Ford plant, I think, in Dearborn, Michigan. At this point, you can see the cars sit on a line here, right? Think of when you go to an amusement park, right? You get on either a roller coaster or some of those rides at like Disney World, and you're on a little track and you're being pulled along for the ride. It's the same principle, but it's applied to the manufacturing of goods. In this case, cars. And you can see here, right, as the cars come down the assembly line, now here's where they attach the roofs and everything. And it created the ability to produce cars on a massive scale. And it's exactly what brought cars to the people. The first example was, of course, for those of you that are familiar, the Ford Model T, which was developed, I believe, in 1908. And this was also, again, as I mentioned earlier, if we go to the next slide, the key as well to continuous production is the standardization of products. Every part was standardized. And in the case of Ford's assembly line, this was certainly true, where you had dies that were standardized, stamping of metal to make shapes and these kinds of things were all standardized to that point. And as the cars moved along, workers would then add engines. And then before it got to there, they would work on the engines and the chassis and all these kinds of things. But standardization was key. And you can see an example of this in Ford himself when he said, you know, you can have the Model T in any color you want so long as it was black. And it's, of course, Ford making a joke that they only made them in black, right? Because it was about standardization. And this is a key thing for the Industrial Revolution of the late 19th and early 20th century, was the mass standardization of everything, nuts, bolts, tools, these kinds of things, is what made it possible that you could move in parts continuously, right? When your car breaks down, you get a specific part, right? It's all standardization. It allows for this massive production of something as large as automobiles. And it also, again, is what made a lot of these products affordable to your average person, cars especially, right? So it wasn't until the 1920s where you started to see everyday people actually owning cars. And by 1920, Ford was producing 1 million cars per year. And a lot of this was made possible by the fact that if we looked at the assemblies of chassis, just to give you an example, which is kind of the building blocks of the car, the kind of frame thing it sits on, that kind of thing. If we look at the example, pre-assembly line, it took 12 hours to assemble a chassis. Once Ford introduced the assembly line in 1913, they could do it in 90 minutes. So they were producing hundreds of cars a day, specifically. And then from there emerged this idea of scientific management, particularly in these things called time motion studies, which I'll explain just very briefly. And again, Frederick Winslow Taylor's piece, The Principles of Scientific Management, is probably the most influential book written about business principles in the 20th century, perhaps ever. It is the beginning, in many ways, of the scientific and rationalized approach to business, the beginning of business schools as well. So what is motion studies? Well, time and motion studies is a technique for business efficiency that combines the study of Frederick Winslow Taylor's study of time with the motion studies of Frank and Lillian Gilbreth. Time study was about developing standardized times, while motion was about improving work methods. So a lot of these assembly lines operated on a standard time, right? The actual assembly line moved at a specific pace. Workers knew what that pace was. They knew exactly how much time they had to finish it. And this was key, right? Is figuring out exactly how much time a worker needed to install something, right? And having that margin of error come so close to as long as it took that worker then to move on to the next phase of the assembly line. And this is what allowed these assembly lines to move and be so efficient. Now, these methods were combined for improving and upgrading working systems. And this is the beginning as well of this idea of a manufacturing system. And this also relates to what we talked about earlier about the interchangeability of workers, right? The system for Frederick Taylor was what was important, not the worker. You had to train the worker to understand the manufacturing system. And the whole idea was that the worker himself becomes part of the manufacturing process and can be interchanged just like interchanging a part or a machine in that process. It's what further led to the de-skilling and, again, the decreasing of wages in that particular area. The only reason wages go up, as we'll talk about next class, is because of the massive unionization movement of the 1930s. But manufacturing jobs in and of themselves do not actually pay well, despite the nostalgia for manufacturing jobs that exist today. And we'll talk about this next week. What they're really nostalgic for is that period of the mid-20th century we're going to talk about next week. So Taylor is key to it all. And eventually, these studies in time motion would lead to the emergence of methods engineering. It's the principles of engineering as applied to the manufacturing process specifically. Now, I'm going to leave it at that. For now, and I'm going to go into more detail in the next video. It'll probably be two more. First, what we're going to look at is the emergence of the modern corporation, specifically how it becomes vertically and then eventually horizontally integrated.